So, Dan, before we get started on this topic, I wanted to let everyone know that they might not be aware that you and I are starting a technical podcast. So, if you haven't checked it out, check out the click down on any podcast platform. And talk.
So I was just going to ask you, Anna, when the first time we tried to record the podcast, what happened on your end?
Well, my neighbor decided that it was a great idea to cut down a tree. And so I ended up having to hide in my closet so that you couldn't hear the tree being cut down.
And I do have to say the one nice thing about not having to travel all the time is avoiding the noisy neighbor in the hotel. I mean, I think we've all kind of experienced that. You have the heavy walkers, you've got the loud talkers, the alarm clock bandit, that person who leaves the alarm clock running after they've left. And then, you have the television watchers. So all these things just impact just trying to relax in your hotel room. And so if you think about how this noisy neighbor scenario equates to the world of VDI, it can really have a serious impact on the whole user experience.
Yep, for
And to
sure.
talk about this more, we're bringing in one of our experts, Alan Formansky, who knows all about the noisy neighbor. Welcome, Alan.
Thanks, guys. Great to be here.
So, in VDI, what is a noisy neighbor?
That's a great question, right? A noisy neighbor, what is it? How do we detect a noisy neighbor? But just kind of to your point, guys, right? Noisy neighbors, that's something we deal with in everyday life. It could be the trumpet player in the apartment next to you. That's definitely going to be a noisy neighbor. Or perhaps the more common scenario, that's grandma rocking out on that electric guitar. Well, you're just trying to have a nice, relaxing evening with your significant other, right? So
No,
how do we?
no. Is that a personal thing that's actually happened?
Uh, no, it's not a personal thing. That would be pretty cool, though. But no, not a personal thing. But nonetheless, a noisy neighbor. So how do we handle these noisy neighbors? Well, first, when we talk about noisy neighbors, let's talk about the Citrix variant of the noisy neighbor. And you might recognize this clip, Dan. This is the noisy neighbor from the Citrix perspective, which involves one host where you have multiple users connected, right? So a hosted shared environment. And there's one user that's just pegging the CPU. It could be an Excel macro. It could be some other CPU-intensive application. And as a result of that, that affects the other users on the box. They're a noisy neighbor. Performance is degraded for the other users. And what happens? Well, users can call the help desk. They don't get work done. At the end of the day, it ultimately costs the company money. No good, right? No good. All right, so now that we know what a noisy neighbor is from the Citrix perspective, how do we go about detecting the noisy neighbor? And you know what? There's a good chance that you have at least one or more noisy neighbors in your environment. Noisy neighbors tend to be knowledge workers or power users because we're giving them more, quote, instruments with which to work, but they can also be task workers as well. So for this, we use our Citrix Analytics offering. This is our Citrix Cloud delivered offering. It's the performance variant. We also have Security Analytics, which is a separate offering that looks after a zero trust approach across the entire workspace. But let's dig into Citrix Analytics and how it will actually help us. All right, so within your delivery infrastructure, there's a vast amount of data that's always being generated. And we need to make sense of all this data, especially in the context of performance. So bringing in all this data, things such as user session information, VDA, applications, delivery groups, we ingest all this within our Azure-based machine learning platform and then make sense of it for admins. So what we're ultimately doing is we're saving admins time so they can focus on areas that need attention. The users will automatically get assigned a poor, fair, or excellent score overall, and this is dynamically generated every 7 days in the environment. So it's pretty cool software if you haven't had a chance to experience it. We've got some links towards the end. All right, but let's dive right in now and take a look at an actual demo. So this is the Citrix Analytics console, and you can see that we have the breakdown of excellent users, fair users, and poor users. So what we're going to do here is we're going to drill into the poor users and take a closer look at what this consists of. All right, so we're going to simply click that link and drill into our 700 plus poor users. Now, as soon as we do this, you'll notice that analytics breaks it down in various categories. So we have our session availability, session responsiveness, and each one has proactive insights and recommendations. But we're concerned with the overloaded machines, of which we notice that there's 12 of. So we're going to drill into the overloaded machines and take a closer look. Now, as we do this, it brings us to an area of Citrix Analytics called self-service, or the query area. And it automatically fills out the filter parameters for high CPU and high memory. These are the machines that meet that criteria, and we're going to go ahead and take a quick look and then filter by sustained CPU activity, right? What are the machines that have the highest CPU utilization? Okay, so we've done that, and now we can filter across different areas of time, and it provides us a very nice way to kind of look at a historical perspective of what's happening in the environment, even though the data is near real time. So look, here we have a particular host that had close to 100% CPU utilization, and we're also noticing some spikes in a particular area of the timeline. Now, these spikes directly correlate with the red that you see here on the little bar chart, and those are users experiencing poor sessions. All right, so before that, we didn't have any users with poor sessions. Then we have some users with poor sessions. And notice that the session count is remaining fairly consistent, and in some cases, it's even decreasing. Once the CPU consumption subsides on the host, then we can see here that the red sessions, aside from this one outlier, have decreased. Okay, so this is just one example of the noisy neighbor with an overloaded host, but we don't necessarily need to have an overloaded host in the environment. So for example, here we have a host where you'll notice there's only 4 total sessions, but yet there's a user experiencing poor performance, and they do so at that same time correlation when there's a CPU spike. So this is a very good indicator that we have a noisy neighbor here. They're pegging the CPU, and it's adversely affecting the other users, even though it's a few, on that particular host.
That's really cool, being able to correlate the timelines and the CPU going up with the poor performance. And I don't think a lot of people realize that the overloaded CPU doesn't necessarily mean that that the machine has to be sitting at like 100% CPU utilization for people to have a bad experience.
Exactly, Dan. That's a key point that's often overlooked by admins. They think, oh yeah, my utilization is well below 80% or 70%, so that's not a factor. Well, that's not entirely true, because we can peg the CPU and still affect other users on that particular VM. All right, so we've taken a look at how we... Oh, go ahead, Ina.
No, I was going to say that I think in the past, in order to get all this information, you needed to go into multiple tools to just figure all this out, where with performance analytics, it's really cool that you already have all the information getting fed into performance analytics, and you get that correlation so that you only need to go into one place to figure out what is happening.
Exactly. And Citrix Analytics, it's differentiated from other tools like Citrix Director and HDX Insight because of the prescriptive nature of it, because of the machine learning, and the fact that it really takes out all the guesswork. Yeah, great point. All right, so now that we've detected that we have one or more noisy neighbors in the environment, how do we go about remedying the problem? Well, that's where Workspace Environment Management comes in, or WEM, and that's going to let us tame the noisy neighbor problem. So the WEM solution, it's a fantastic offering that we've had for a few years now, and when people ask about WEM, I say if you don't have it implemented, you're literally leaving money on the table. It helps you best utilize the resources you have. It prevents issues and resolves issues such as noisy neighbor, but far more than that, just efficient utilization across the board, optimization of CPU and RAM. It's also going to help you improve the logon process for users. Just fantastic solution. And it's a lightweight architecture where we have the agent, our backend database, and then we've got our management console, and you can take advantage of it in either the cloud format or on premises. The numbers speak for themselves in terms of what customers have realized from a savings perspective. And look at this chart here. This chart compares the noisy neighbor from an Azure perspective. So if you take some common Azure VM types, which we've gone ahead and done here, you'll notice that if you compare RDP versus Citrix CVAD, you've got a savings with WEM in the mix. Quite a bit, actually. In some cases, over 40%. So WEM is a fantastic solution. And now we're going to take a look at exactly how it helps you fix the noisy neighbor problem. All right, so we know we've got multiple users on a hosted shared system. That means they have multiple applications, and of course each application has multiple processes, and it's ultimately the threads themselves, right, within the processes that are getting all the work done. But all it takes is just one outlier, just one process with one or more threads to start pegging the CPU for a somewhat extended duration, and that's going to affect all the users on that host. So here, if we have application 4, for example, that's acting up, WEM will automatically detect that over the given specified duration that we'll look at, and then it will, in real time, adjust the priority accordingly. This is going to prevent CPU starvation such that the other processes and corresponding threads will still have access to CPU scheduling, and the overall performance will be preserved. No help desk calls. Now, once the application becomes in check and it reduces its CPU consumption over a given specified duration, that priority will go back to normal. And WEM takes care of all this for you automatically with a full paper trail of what's actually happening in the environment if you should need to go back and take a look.
So do you have to configure WEM, like I want WEM to monitor these different executables to handle the CPU optimization?
Yeah, that's a great point, Dan, and that leads into the overall configuration. So in short, it's a feature that we can turn on globally, but WEM does also offer the ability to get granular by specific executables should you choose to do that. And the feature that we're looking at here in WEM is the CPU management, specifically CPU spike protection. So it's quite straightforward. You go ahead and you enable this feature, and then there's 3 parameters that you'll enter. The first is the CPU usage limit. Okay, so if we have it at 70%, whenever the CPU usage for that process goes above 70%, WEM is going to kick in. 30 seconds. So that's the duration of time that we will wait for that to be acknowledged and then automatically reduce the priority for that process. Now, as that's happening, eventually, hopefully, right, the process will, quote, behave itself, and then we'll be able to reduce it back to standard normal priority. That's where the idle priority time comes into play. And here we have it set for 3 minutes or 180 seconds. So detecting that we actually have the problem, WEM taking action, and then going ahead and detecting that the situation has been resolved and re-elevating it back to normal priority. Some pretty cool stuff here, guys.
So that's pretty fast. You know, if you think about it, you know, a user is going to be in their VDI session. All of a sudden, it's like, oh man, everything's starting to run slow. Most people are going to wait longer than 30 seconds before trying to call the help desk. You know, they're going to wait like 5-10 minutes. So the system should auto-correct itself, it sounds like.
Exactly. Dynamically adjusting in real time to preserve the overall performance of the session, while at the same time still allowing this excessive process to do what it needs to do, just at a lower priority. And that provides a better fair share of handling. You'll notice that there's other options here in WEM, things like CPU priority that allows you to really specify a priority for the processes, CPU affinity where you're making assignments for specific CPU cores. CPU clamping is another one. That one's a little bit more aggressive, but that one will prevent the process from ever going beyond, say, 70% or 80% if ultimately needed. And of course, while you're here in WEM, absolutely take advantage of the memory management capabilities and some of the other optimizations. We know that published browsers can be a big memory hog, for example, and that can definitely help you out from a scalability perspective.
No, that's
all right, so to
great
wrap up here,
information, Alan. And just real quick, just to clarify, WEM is available on premises and as a cloud service. So if the customer doesn't want to set up additional infrastructure to take advantage of WEM, they're able to utilize that service, correct?
Absolutely, absolutely. That's a great point. And you can utilize the WEM cloud service even if you don't have the apps and desktop service, for example, but just still let us handle the backend database and management console, quicker time to value. Yep.
Awesome.
All right, so just to kind of recap here, we've detected the noisy neighbor, we've corrected the noisy neighbor, then in time, you'll check back in your analytics console, and you'll notice that that number for users with poor UX should hopefully be driven down. That's the ultimate goal, and it's just fantastic visibility that Citrix Analytics provides, so you can see that trend. Now again, there's a number of other factors that do affect poor user experience, but the noisy neighbor is absolutely a key one, and it's one that you want to address in your environment. All right, so we've got a couple next steps, things that we'd recommend. Obviously, we're TechZone Live, so check out the fantastic content that we have on TechZone. From the analytics side, we've got a variety of different docs. From the workspace environment management side, we've got an excellent reference architecture. And then we've got all the standard documentation, and then try it for yourself. Just give it a spin. We have trials for both. In fact, if you're a CVAD customer, you may already be entitled to workspace environment management on premises, or as Anna mentioned, take advantage of it as a cloud service, a lot more turnkey. And that's what I've got today.
Yeah, you know what I like about that is a lot of times you just don't know if this is your issue. You know, it's like users are complaining that things are running slow. It's like, oh, well, yeah, analytics tells me that my machines are overloaded. Okay, now I know how to fix it.
Exactly. And data that, again, you wouldn't otherwise get in Director. Director's fantastic at the day-to-day, the help desk staff for session shadowing, but it's not going to give you those true deep insights or, quote, analytics like Citrix Analytics will.
Yeah, for sure. Well, Alan, we really appreciate you coming on and telling us more about performance analytics and how we can utilize that along with WEM to get rid of all our noisy neighbors. So thank you so much for joining, Alan. We'll talk to you soon.
My pleasure. Thanks for having me, guys.
Thanks, Alan.